how good a job did you fundamentally do? Now, I'm going to be looking at test coverage different than most people. If you go in and have a problem with your computer, you're going to say, if I did this, and I did this, and I did this, it didn't work. That's a combination of 3 things. It's not 20 things. So what I'm going to be suggesting is that we want to look at how good a job do we do for combinations of 3 things, 2 things, maybe 4 things, and 1 thing. Because we're saying typically when we get 5 or 6 things, usually that doesn't happen. Usually when we get a problem, it's a combination of 3 things. So that's what I want to do, is describe test coverage in terms of what I call combinational factor levels. And I'm going to be talking about 2, 3, or 4 things. Since many problems are described in combination of 3 things, we're going to use that coverage, or combination of 3 things is what I'm going to be focusing primarily on. So if somebody does this, this, and this, does it really work or not? So what percentage of all possible combinations do we cover? Now, this is my book. I didn't bring it with me this time, but in Implementing Six Sigma, that came out in 2003, the 2nd edition. It's not included in my new books here, but there's a table O in the back of that book that describes the test coverage. When you got 2 levels of factors for the particular designs that I've included. So this is what table O looks like. So as you see, group size down here represents the number of factor and their levels that we would be considering. So if you got a group size of 3, you'll be coming up looking on here. Now if you use the tables in the back of my book, I have design of experiment matrices for 8, 16, 32, and 64 trial matrices. So you can have actually 63 factors in 64 trials if you're really glutton for punishment. But they're really set up primarily for our design of experiments. So that's even more than mini-testing. But and then I got all the alias instruction that goes with it. But we're going to be using those particular matrices to go in and look at it using this pass-fail functional testing. So, for example, if we go in and do 8 trials in group size 3, now in that case we could actually look at 7 factors in 8 trials. Okay, so we got 7 factors, each of at 2 levels, and we're only doing 8 trials. We can go in, if you look up here, follow the black bar, which is 8 trials, you'll notice that you get 90% coverage. So I'm doing basically 90% of all possible combinations of factor levels that you might have. Okay, somebody should be getting a goosebump here. I don't know. That's a really good coverage for so few trials. Now, let me show you the mathematics behind that. Okay. Now, well, let me first show you the summary of that. So if you look at group size 2, you're actually getting 100% coverage. So if I pick any 2 factors and I pick any levels of those 2, and then I got 100% of coverage of those. Like I said, the 3 here is that, 4 and so on. Now, it turns out there's 280 possible combinations in group size 3. Okay. So 8 trial provides 90% coverage of 280 possible combinations in group size 3. Now let me show you how you calculate that. Okay? So this is just dealing the number of possible groups of 3, and then that turns out to be 35, and then you go in and run through the math here, and it comes out to 280. So there's 280 possible combinations. So this test coverage statement is kind of approximate. It's really true for 7 factors in 8 trials, but it's almost true for 5 or 6 or 7 factors in 8 trials, because you might not have 7 factors. So it runs out to the same coverage. Now, if you look at it and say, why do you get the same percentage? Well, it just turns out that way mathematically, but each trial, if you have 7 factors versus 5, it has a lot more reasons why it could fail, because it's got more factors associated with it. So if I'm moving too fast, or if you got a question, be sure to jump on in. We're covering quite a bit of ground, and I know this is somewhat new material for most people there. Are we okay? Yes, sure.
So is the assumption here that the factors are independent of each other, so that it doesn't matter in what order you choose them? And the reason I'm thinking of this is if you're applying this to, say, testing your software,
Right.
and basically you have, in a menu of items, you can make a finite number of choices. Once you make a choice there, it offers a different finite number of choices that isn't available in any other menu item that you might have chosen at the top level.
Yeah, they're independent. I mean, you're assuming that.
So you're assuming basically that all the menu items at every lower level is available for every single menu item at the top level.
I'm also assuming that you can run in all the combinations.
Right.
So sometimes you might, for this example, now I'm going to be showing you a software program later that you don't have to assume that. But for this situation, I'm assuming that all possible combinations are legitimate. Okay? So now similarly for 16 trials, we can get about the same coverage for 15 factors all the way down to 8 factors. In 32 trials, similarly 31 to 16 factors. So keep in mind, 32 trials, I can do 31 factors at 2 levels. Now, question when a failure occurs, the combination may be obvious to somebody on why it failed. But again, to really reiterate that you may need to do a search pattern strategy to find out the problem if it's not so obvious. Now let's look at an example. A company is considering buying several new personal computers, okay? And they got some unusual situations. Okay, so they got some situations that they want to test out to make sure it actually performs well. Now, the company believes that there's probably not going to be any problems if they run these various scenarios at these 2 different extremes. So in other words, if it works at high and low level, it's probably going to work somewhere in between. So what typically I do is then I brainstorm for the factors and the levels that we might want to consider. So this works out really well in the team environment for what factors do we want to consider. Now in this case they're looking at 4 different types of printers that they might use. I believe that if we ran these 2, that the other 2 would probably work okay, because those represent technically maybe the more extreme situations. So we had sometimes 2 displays work concurrently, or you might have just only 1 display. Again, my example here is somewhat dated, but hopefully you can bear with me and translate it to more real-world factors that we might have today. You might have 2 different word processor packages, and then you could have 2 different database managers and 2 different spreadsheet programs, before Excel was the only thing on Word. So, and also you might have a plotter, you might not have a plotter. So the other thing, you could have some networking situations that you might have. So you see how the logic that we're looking at this, we're really looking at this from a big picture system point of view. So basically, using this logic, this is the factors we came up with, so the A through G and the levels of those factors. So if we go in and look at this, we've got 7 factors, so we could actually do it in 8 trials. Okay? So for example, trial number 1, just to bring you into the real world of what you might have, would be printer Y with 1 display, processor X, database, so on. And the idea is when you go in and test this out, it's supposed to work, because it's a legitimate configuration. So it's first to build various configurations and then to perform the test cases so that you stress it until failure. So you're really hitting this configuration hard. You're really getting the right people that really know how to go in and test this configuration. So as an additional scenario, just